Hello class. Well, we are ready for the last unit of Math 113. So we're going to do lesson 8 and I'm going to perhaps get number 9 on here also. We'll see how it goes. So we're going to be graphing linear equations. We covered some of this in 111 and 112. So linear equations have just the x. Ax plus by equals c. If you remember, if we have the x squared, that's called a quadratic. But these are linear equations, and that's what we're going to be doing is graphing lines. So just a little refresher here on the graph. The vertical axis is the y-axis. The horizontal is the x-axis. If we have a point here, this is called the y-intercept. And this, if it's on the x-axis, is called, guess what? Yep, you're right, the x-intercept. And if we have those two values, we can make a line. All the points are represented by the letter X and Y. So if I have 2, 3, that means the X is 2. So we start here. This is called the origin 0, 0. I don't know why I made a dot there. This is the origin where you always start. Origin means the starting place. So if I have 2, there's 1, 2, and then up 3. 1, 2, 3. Over 2, up 3. So that lot point would be right there. Now, getting kind of messy on there. Let's get rid of that. Let me put the graph back up here. Again, this is the y and this is the x. So let's say we have -3 and -2. The x is -3, so again I start at the origin. I go 1, 2, 3, and -2, it goes down. So 1, 2, 3 to the left and 2 down. That would be my point, -3, -2. Every point in the first quadrant here is going to be positive, positive. This one is going to be x will be negative, y will be positive. Down here is going to be negative, negative. And over here is going to be positive, negative. So if I ask you, okay, this is quadrant 1, 2, 3, and 4. So if I say I have 7 and -3, you're going to immediately know that's going to be in this quadrant right here because it has a positive 7 and a -3. If I have a negative, negative, which I did here, negative, negative is in quadrant 3. So if you'll remember, that's how we learned to do the graphing last time, and we're just going to go a little farther with it this time, but I just wanted to give that little refresher to you. So we're going to be looking at the slope, which means how steep something is. And I'm going to tell you that a horizontal line has no slope. I'm sorry, it has a slope. If you're laying flat, your slope is 0. So it has a slope of 0. If we have a vertical line, it has no slope because it ends up with a 0 in the denominator. So we just call that no slope. Okay, so slope tells how steep something is. If you have parallel lines will always have the same slope. So notice parallel lines have the same distance between them. So if this slope is, say, if this slope is say 4, this one's going to be 4. If this one's 1/4, this is 1/4. Whatever this one is, they're the same. They have to be because they never meet. And then on a perpendicular line, the slope is the opposite reciprocal. Okay, so if we have a perpendicular line, means that they meet at right angles. So if the slope of, say, this line is 2/3, positive 2/3, then the slope of this line, we're going to take the opposite of positive, which is negative, and flip that, which is 3/2. So it's the opposite reciprocal. So that's how those are related. Now, moving right along here, if you're given 2 points and you want to find out the slope, let's say you're given the points 2, 3, and 1, 5. To find the slope, we have m is equal to y2 subtract y1 over x2 subtract x1. So what I want you to do until you get familiar with this is to actually come over here and call this x1, y1, x2, y2. Notice I just put those little numbers down at the bottom to just differentiate between the two. All right, so this one's going to go here, and this one's going to go here. So we're going to have 5 subtract 3 over 1 subtract 2. 5 subtract 3 is 2. 1 subtract 2 is -1. So we always call the slope m. Don't ask me why, because I don't know. M is equal. So we're going to have this. M is equal to 2. And we can put that negative wherever we want to. We can put it up here or we can put it down there. I'm going to put it on the top just because I like to do it better that way. So the slope for this is -2 over 1. And I usually leave the slope in fraction form, and you'll figure that out later. If you're just asked to find the slope, you can certainly just say that equals -2, and that's correct. But if you need a fraction, you can put a 1 under it. That'll make sense to you here in a bit. Now, we have one more formula, and it's the distance formula. And it finds the distance between 2 points. Distance between 2 points. I think I forgot to tell you that this should be on page 22 of your book. And it says that the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance between 2 points. So let's use the same points that I had a while ago, the 2, 3, and the 1, 5. And again, this is x1, y1, x2, y2. So I'm going to put that in the distance formula to see how far it is between those. So I'm going to have 1 subtract 2 squared plus 5 subtract 3 squared. I just took the numbers here, popped them in there underneath the square root sign. 1 subtract 2 is -1. -1 squared is 1 because a negative times a negative is a positive. 5 subtract 3 is 2. 2 squared is 4. So I have 1 plus 4 under the square root sign, which is equal to the square root of 5. So the distance between those 2 points is equal to the square root of 5. And then there's there's another form that you need to know. Another little formula. This is my favorite one in working with these graphs, and that's called slope-intercept. Slope-intercept form. And it says y equals mx plus b. So on this, m is always equal to slope. B is equal to the y-intercept, where it crosses the y-axis. So, knowing this, if I want to graph, let's say y equals 3x subtract 1. I believe this is example 1 on page 22. So looking here, this is M and this is B. So I have my graph. Excuse me, I want to make sure all the graph's on there, and it's not. So let's move it over here. I have my graph here. This is Y, this is X. It'll always be the same, and this will always be where you start. It's right there in the middle. So B is -1. That means it's going to cross the y-axis at one spot below the origin. M, which is the slope, is 3 over 1. The 3 is the y value. The 1 is the x value. So the y from this point goes up 3, 1, 2, 3, and to the right 1. Once again, this is your y-intercept, the -1. And then your slope, you start at that intercept, and whatever the y is, if it's positive, you go up that many. If it's negative, you go down that many. And then whatever the x is, you go to the right that many places. Those 2 points will give you the line. And again, that was example 1. Okay, so on page 23, I'm sorry, we got one more example to do on that page. Example 2 is y is equal to -1/2 x, and that's all it is. Well, I need it in this form. So, my friends, I'm going to make that be a 0. So my slope, again, is -1/2. And remember, you can put that negative here or here, but I personally like to put it in the y spot. You can put it down here if you want to. We'll come up with the same answer, and life will be good. Okay, and what's my b? What is my y-intercept? It is 0. Then I take my slope down 1, to the right 2, down 1, right 2. And then connect those lines, connect those dots with a nice straight line, and you'll have your graph made for that. Again, if you have just an x term here and nothing over here for the b, stick a 0 in there and put it in the origin. It'll just make your life easier. Now we're going to go to page 23. Example 3. So let's see, that's y equals 4. When you have just a letter here and a number here, the easiest thing to do is make a little table. What's y equal to? It's equal to 4. What's x equal to? Well, you get to choose. I always choose 0 first. That'll give me 1 point. And then you can choose maybe 2 and negative 2. That would be a good choice. So let's graph that. 0, 4. Right there. 2, 4. Right there. Negative 2, 4. Right there. So there's our line across there. And the slope of that line is 0 because it's flat. 0, no slope. That's why we can just say y is equal to 4, because when you have y equals 0, x plus 4 just means it doesn't have, it has the slope of 0, and it doesn't have that term because it just zeroes out. And then we go to example 4, which is x is equal to negative 1. Again, when you have a letter here and a number here, it's probably easier to see if you just make a little table. And this time, negative 1 will be in the x spot. Again, choose 0, and then 2 and negative 2 will be fine, or if you have something better, use it. Negative 1, 0, right there. Negative 1, 2, right there. Negative 1, negative 2, right there. Well, look at that. It's a vertical line. And remember, a vertical line, it has no slope because we'd end up with 0 on the bottom. Okay, and then we've got one more, example 5. Example 5 says 2x plus 5y equals 10. Always put it in this form, solve for y. So here I have 5y, so I'm going to subtract 2x from both sides. And notice what I'm going to do here. I'm going to put that negative 2x first because I want it in that form, plus 10. Now I'm going to divide by 5, divide by 5, divide by 5. So y is equal to negative 2 over 5x plus 2. Once you get it in this form, you'll come over here and you're going to graph it. What's the y-intercept? 2. 1, 2. Put it out there. What's my slope? Negative 2 down 2. 1, 2. To the right, 5. 1, 2, 3, 4, 5. Maybe that's not exactly equal, but down 2, 1, 2, 3, 4, 5. Looks like it's going to be right there. And you'll make your line. Okay. I do need to go over another little formula for you to be able to do number 5 on your homework, and it's called the point slope formula. Point slope formula. And what it says is y minus y1 equals m times x minus x1. And what you do is, if you know the slope and you know a point and you know the slope. And so I'm going to tell you that the slope is equal to 2, excuse me, and it passes through the point 2 and negative 3. So I'm going to come over here, and y, I'm going to leave it like it is. This is y1 and this is x1. So y minus a negative 3 is equal to, the slope is 2 times x subtract 2. Let's go ahead and get, that's kind of messy. Subtract the negative is a positive, so y plus 3, and let's distribute here, 2x minus 4. Now I need to get it in my y equals mx plus b form. So I'm going to subtract 3 from both sides. So I end up with y equals 2x minus 7. And that, my friend, is your equation. Now, if you were given, if I tell you m is equal to 6 and b is equal to 3, and I ask you to write the equation, you're going to say y equals, using this, 6x plus 3. And that's all you have to do if you're given the slope and the y-intercept. Now, let's see. What if I told you that I have the points 4, 2, and 0, 5, and I want you to find the equation for the line that passes through those 2 points. Well, first of all, you need to find the slope. The slope is equal to y2 minus y1 over x2 minus x1, which we've done. And so let's go ahead and do this. 5 subtract 2 is 3. 0 subtract 4 is negative 4. So my slope equals negative 3/4. Now, I have a point. I can choose either one of these. I'm actually going to choose this one. So you choose a point. You know that your slope is negative 3/4, and now we're going to use that point slope form, which was y minus y1 is equal to m times x minus x1. So y minus, again, I chose this one right here, so y is 2. So y subtract 2 is equal to my slope, which is negative 3/4 times x subtract, and I chose that one, so it's 4. Okay, let's go ahead and distribute. So I have negative 3/4 x and negative 3/4 times a negative 4. It's going to be a positive 3. So I have y subtract 2 is equal to 3/4 x plus y minus 2 is equal to negative 3/4 x plus 3. So if I add that 2 to both sides, we're going to have y equals negative 3/4 x plus 5, and then that would be your equation. Okay, I think I'm going to stop here, and your next lesson is going to be a really short one, but this one's kind of long. This will get you through all of lesson 8 and most of lesson 9.